Ohio, Austin, Texas. Okay, good morning, everyone, and welcome to Sage Live in March 2024. My name is Anna Llobet, and some of you know I'm a physicist from Los Alamos National Laboratory here in New Mexico, and also the lead of the Summer Physics Camp for Young Women, which is the Sage Camp in New Mexico. Before we start, let me briefly explain what the Sage journey is all about and how Sage Life fits with that journey. Sage Journey is a program whose mission is to inspire, encourage students to explore STEM careers for their future. We do this by offering free summer camps. Some of you attended. Also paid internships, and we are very busy now with those internships and professional growth sessions and many opportunities to connect with professionals like the ones we are going to have today who care about you and your future. Sage Life is part of Sage Journey. A journey is like step by step, right? And Sage Life is an online gathering of students who have attended summer camps and are curious about the next steps in their Sage journey. It's also a time to reconnect with Sage volunteers. You saw some of us very excited to see a past student. So that's fantastic. And it's held monthly via Zoom between the months of August and May. The topics covered are relevant to your journey, whether it is career related, such as designing your life, resume workshop, or how to prepare for an interview, or new and exciting topics such as quantum computing, artificial intelligence or machine learning. Today, we will talk about artificial intelligence and Chat GPT with Karin Verspoor, Professor Karin Verspoor. And this topic came proposed by one of you. So here you are, we are listening. So Professor Karin Verspoor is Dean of the School of Computing Technologies at RMIT University in Melbourne, Australia. And that's why we changed the time of the Sage Live today. She didn't want to have to be talking at 4 a.m. Karin's research primarily focuses on the use of artificial intelligence methods to enable biological discovery and clinical decision support. Through extraction of information from clinical text and biomedical literature and machine learning-based modeling. Karin held previously post as Director of Health Technologies and Deputy Head of the School of Computing and Information Systems at the University of Melbourne, as the Scientific Director of the Health and Life Sciences at NICTA, Victoria Research Laboratory, and at the University of Colorado School of Mines, and some years ago at the Los Alamos National Laboratory, where she and I met. She's also the Victorian Node Lead and co-founder of the Australian Alliance for Artificial Intelligence in Health. And I know all of you might think, oh my goodness, that's a mouthful. Well, guess what? She's also a mom and worries about moms and parents things. And she also had pets. So that's, a lifelong professional career. So with that said, Karin, would you like to go ahead?
Yes, I think Anna got cut off. Hello, everybody. Can you hear me? You can hear me?
Yes, we can.
Yeah.
Good. All right. Excellent. Well, yes. Good afternoon, everybody. Good morning. It is actually Sunday morning here in Australia. And so, yes, as Anna said, that's why we had to push this a little bit later just to allow me to sleep a little bit. But it's super hot here today. And so honestly, I didn't sleep that well. I actually could have done this talk at 4 a.m. because I was awake. But anyway, I did go back to sleep. So haven't been up since then. Yeah, so I'd like to first of all just take a second. This is something that we do in Australia, and it's really important to just acknowledge the land that we're on. We're very cognizant of the fact that we are visitors to these lands that we live on at the moment. And so I'd like to just take a moment to acknowledge the lands that you're on as well, and the people that have been there for thousands of years, perhaps in some cases. So I'm going to do a little bit of scene setting because we can't talk about Chat GPT without talking about what a large language model is. And I'm a technical person. I am a computer scientist. And I've been working, as Anna said, on natural language processing for a really long time. In fact, I started doing natural language processing when I was an undergraduate student at RICE University in Houston, Texas. And so I've been in this world of trying to get computers to make sense of language for a really long time. And, you know, as sort of building on what Anna was talking about earlier, AI is not going to go out of fashion. Natural language processing is not going to go out of fashion. It's been around for a really, really long time. I think it's always important to remember that. But what we're seeing now is a massive scale up, right? So these systems have just gotten bigger and bigger, and the amount of data that they have access to is bigger and bigger. So let's talk through a little bit about how they work under the hood. So a large language model, it's named that because, well, it's large, right? Meaning it's basically huge. These models have 175 billion or even up to 100 terabyte parameters. Parameters are basically just numbers. They're weights in a model. Language, well, it's capturing patterns in natural language. Actually, it's really capturing patterns in any text that we can find and access in digital form. So there's also code in there, and there are data tables and all sorts of other numerical strings. Anything that is on the internet, basically, these language models are consuming. But the idea is to try to make them capture the patterns of how we use language as we write it down in written form. And a model, well, a model is just it's just a representation, a mathematical representation of the patterns that are in the language, which allows us to then kind of reproduce the sequences that we see in the language. So in a nutshell, it's a statistical model that approximates the structure and characteristics and patterns of language. How do we build this thing? Well, we feed it huge amounts of text. So we collect as much text as we can, again, from the internet primarily. And then we feed it into a machine that tries to estimate the probabilities of the word sequences. And in the process, we convert the text in its raw form into a mathematical representation. The result of this is that we end up with a big, very high dimensional space of words, essentially, and a mathematical vector that corresponds to each word in the language. It's actually a little bit different than that, which I'll get to in a minute, but this is the easiest way to think about it. So you can think of words as points in space. And the idea in trying to assign these vectors, vector is just a list of numbers, basically, that is associated with the word. We're trying to set those numbers in that vector in such a way that the patterns of the language are kind of implicit in those numbers, so that when we do mathematical calculations with those vectors representing the words, it makes sense to us in terms of how the language works. So a word like cat, we expect to be close to other words that have to do with pets, right? So the word pet itself, dogs and kittens, dog, puppy, all of these things should be kind of close together in this mathematical representation. Pigs and rabbits and raccoons might be a little bit further away because they're not quite as canonical in terms of cat. So in the simplest model, we have exactly one vector per word. And we are trying to ensure that words in similar contexts have similar vectors. So words that kind of relate to the same kind of topics should be close together. So what's the idea here? So when we try to learn these models, we're actually trying to trick the language model into understanding what words go together. That's really what it's all about. You know, the mathematical representation is about capturing the similarities between words, and the way we learn it is to get the model to understand how those words kind of fit together. So if I put this fill in the blank test up there for you, what word would you say goes in the blank? Anyone want to take a guess? I'll see if I can see the chat.
So I can read the chat. Some say eats, sat, goes.
Yes. Okay.
Goes on the mat. Slept on the mat.
Right. So
Wow.
most of you said sat, and that's the most common guess, right? Why? Because I don't know if it's a childhood thing where when we try to teach kids to read, but basically the cat sat on the mat is a very, very common phrase. And so if you think about this in terms of statistics and probabilities, the highest probability word to go in that blank is sat. But as you've noticed, there are other words that can fit in that blank as well. So the cat slept on the mat, the cat goes on the mat, the cat jumps on the mat, the cat, I don't know, does all sorts of
Poops.
on the mat,
Poops
eats
on
on the
the
mat,
mat.
poops on the mat, or it does all sorts of things on the mat, right? But what we try to do with these models is to try to have it guess what word goes in the blank, and then we, sorry, I had switched the chat window, so my next wasn't working. Anyway, so what we do is we reward the model every time it guesses the right word. So we trick it into guessing the right word, a word, by removing the word from an example sentence. And if it guesses the right word, like sat, then we give it a reward. And this basically means that we reinforce the connections in the model to say, yep, your probabilities, your statistical patterns that are captured in this model look like they're going in the right direction. And if we have a word like read, the cat read on the mat, which doesn't make sense because cats can't read, at least the last time I checked, unless we're in some sort of, fairy tale world. Then we would say, nope, you got that wrong, model. That's not a good word to go in that blank. And so we actually, again, adjust down the parameters, the numbers, the weights in the model in order to essentially decrease the probability that the next time we ask the model to guess what word goes in this blank, it has less chance of producing red. Does that make sense?
Yeah, Karen, Mia McDermott was saying, is it the rhyming part of it, or is the making sense part of it that gives penalty or reward?
Well, it's actually just whether there is an example text somewhere on the internet that matches the guess. And so if there is a sentence out there, like the cat sat on the mat, then that will result in the reward. So we say, yep, there's a real world sentence that matches this particular pattern. And so we're going to give you credit for that. But if we can't find a sentence that matches the pattern, then we're going to say, no, that was a bad guess, and try to compensate for that. Now, obviously, the more sentences there are that have a particular pattern, the higher reward we're going to give for guessing the right thing. And that means that because the cat sat on the mat is something that we hear a lot, or more importantly, write a lot, it's something that will be reinforced more frequently, and therefore it makes it even more likely. Does that make sense? Okay, cool. So how does this all work? Well, basically, it's done using more maths, right?
Karen,
Yeah.
there's a quick question. What do you mean when you say you give the model a reward?
Yeah, so the reward bit of it is what I was saying earlier about essentially reinforcing the weights that are inside of the model. Maybe if we refer to this picture, it'll make it a little bit easier to understand. So basically, we have in any machine learning model, in any deep learning model, you have some representation of the input. So the input in the case of a language model is the words in a sequence, right? So basically a sentence, paragraph, or a whole document. And when we input those words, we have a representation. We turn it into numbers somehow, and basically I could give another whole talk about how exactly we get this process started. So I won't go there, but just assume that we have some mapping into numbers for every word in the input. Once we have those, this is a vector of numbers. Then once we have those numbers, we multiply each of those numbers according to the weights, and then have a function which sums those numbers to produce a value in each of these circles here. And so basically, when I said earlier, somebody I saw in the chat asked, what's a parameter? A parameter is the number that we assign to each of the links in the network. So basically each of these arrows here that you see here. And then there'll be another sort of number that weights the nodes in each of the layers. And so the parameters are essentially all of those weights, all of those numbers that are attached to the nodes and the links in this big network model. And so what we do is we take that input and we multiply it by all of those weights. We add them up in each of the thing, and we push that all the way through. And we just continue that process. So we multiply vectors by vectors by vectors. We keep multiplying all the way through until we produce an appropriate output for the input. And so what happens is if that output is wrong, so if our fill in the blank, for instance, gets the wrong word, and so we want to penalize or we want to reward, there's a process called backpropagation, which basically helps us to say to go back through all of these layers of the model and adjust down the weights. So we say, all right, this output that you gave us was wrong. And so we want to make it less likely that we'll produce that output at this layer. But then we want to make it less likely that we get to that same representation that produced the wrong output at the previous layer. And so we adjust down all of these weights that come into that node. It's a little tricky to wrap your head around, but the idea is that we just, through observing millions and millions and millions and millions of examples of text and having millions and millions and millions of repeated chances for the model to guess the right word, we then adjust those probabilities in the right way so that eventually the network settles on the right numbers, so that when we have a given input, it produces the output we expect.
Karen,
Yeah.
Sanvi was asking that if a sentence like the cat rat on the mat exists in the internet, does the computer get a reward even if it doesn't make sense? Because the internet is a big box, right? There's everything in the internet.
For sure. There's lots and lots of errors in there. But again, because of the fact that it'll be far more rare to have something like that than a correct sentence, we can use that information to help drive the learning process as well. So it isn't, I've obviously simplified it for the purposes of trying to explain it, but it isn't quite, does it ever appear? It's just based on how rare or how likely it is that word fits in the blank.
That also links to Delia's question. Does everyone have the same probability of getting SAT, for example? Can you train these models to be extremely different for each person? Or does everyone have the same general response?
Okay, so there's two questions in there that are, the answer is a little bit different. So does everyone have the same probability of getting SAT? Well, the probability of getting SAT in the model is the same. Once the model's been trained, it's a fixed model. And so the probability of getting SAT is always the same. But the trick that is introduced is that they allow a bit of dynamics in producing these outputs. So you don't always choose the highest probability word in the sentence. You will sometimes choose the second most probable word, which is probably still a perfectly good word to go in the sentence, right? It could be slept, like you all guessed before. It might be, jumped. And so instead of always picking the top most probable word, these models introduce a little bit of dynamics so that we get some variability in the outputs. Now, that's not on an individual level. So getting to the second part of the question, the models are not personalized. And what we're seeing now is that, if you go to Chat GPT, yes, you'll get different answers every time. And that's because there is a little bit of this stochasticity or this dynamics built into the output. And actually, you control it. You can control it. So in some cases, so Microsoft Copilot, for instance, has different modes you can use to control kind of how likely it is to change the answer. Yes, stochastically means probabilistically, basically. Sorry.
No, it's so good. I'm encouraging the students to Google it. But you gave them the answer. What do the Audrey was asking, what do the layers do to the answer?
Yeah, so essentially, because these are all just okay, so what we're doing with the layers, if I'm understanding the question correctly, is trying to build in the ability to capture very, very subtle patterns of representation. So you can have an extremely simple model. In fact, the very first models that try to do this word to vector kind of mapping were literally called word to vec. And it only had one single layer. And that was a good way to start approximating the weights, how we can represent individual words. But by having many, many, many layers and having this process of multiplying things together, we actually find that the connections and the relationships between words in the sequence becomes much more sophisticated. And so essentially, having lots of layers means that we can find, we might find very simple patterns in the first few layers, like what parts of speech these words are. So do we have a noun, or do we have a verb, or do we have an adjective? And so this layer might try to capture some of that kind of linguistic information that's implicit in the use of the language. But then we might find in layers further in that we start seeing phrases that go together. So, a phrase like, I don't know, medical school might be something that is grouped together, or RMIT University. And then we can build on them. And we understand that, universities go along with particular kinds of words. So it's not just, the word university, it's kind of this phrase, this higher level thing that has connections to other phrases and other words through the context. So essentially, it allows us to find increasingly complex patterns by pushing the representation through all of these layers.
That's cool. Maya was asking, so if two people enter the same prompt on ChatGPT, would they get the same answer?
Do you know that, like, you can enter the same prompt on ChatGPT a couple of times and you won't get the same answer? And that's because they are trying to make it not be boring, basically. So yeah, they're trying to make sure, and I've even, like, I've been playing a little bit with some of the image generation tools, which are kind of fun. And I once put in a prompt. I know exactly what the prompt was because I wrote it down, and I created an image, and it was horrible. Like, it just horrified me. I can tell you about it later, but and I thought, oh no, I can't use that. And so I went back and I added the word cute in front of it. And it was a much better picture, and I was happy with that. And I actually told that story to somebody that, like, oh, I'd like to see that image that you were talking about, the horrible one. And I went back, and I've tried many, many times on many different days, and I can't get it to produce the same thing. So
yeah. That's cool. Sanvi is asking if the computer actually learns based on its mistakes, like a human brain, or it's based on trial and error.
It's basically based on trial and error. So obviously these mathematical representations are really good, especially with all those layers in it, right? We can capture a lot of interdependencies between the words and a lot of the complexity of language. but it's nothing, well, I don't believe it's anything like how your brain works, because your brain is, you are grounded in the real world. And a lot of the way that humans learn language has to do with that. It has to do with our physical interactions with the world. Now, these models don't get to interact with the real world, at least not yet. We'll see if that's something that happens in the future, but I think that makes it quite a fundamentally different process. Think of it another way. When you're a baby and you're starting to learn your first few words of language, you've obviously been exposed to a lot of language, but you don't immediately start producing perfectly formed sentences, right? You start with one word at a time, and eventually you have 2-word combinations, and slowly but surely, it takes a fair long while, and until you're in school, really, that you start producing kind of full formed sentences and very coherent thoughts. And so the process for humans is quite different. We also don't have to ingest a gazillion documents in order to be able to talk. So there's clearly a somewhat different process that's happening in humans. And plus, I would say, we understand language, whereas these models really don't. They just model language, right? They just capture the patterns of language. Okay, so maybe I'll go on and I'll try to answer that question that was just put in as I go through. Okay, so we have large language models. Chat GPT is one kind of large language model. And maybe I'll just unpack what GPT means in Chat GPT so you understand where that comes from. So the G in GPT is generative, meaning that it generates text in response to a prompt. The P stands for pre-trained. So it means that it's built one of those models using deep learning, using that process we just described, and that it's then a kind of static representation of language. And the T is the interesting bit. So T stands for transformer. And I'll again just try to give you an intuition of what this is, but it's a particular approach to doing that deep learning process that I described earlier, which allows the representation to fold in the context. I'll put a little picture up in a second just to give you a sense of that. Okay, so we've the generative approach in Chat GPT is essentially trying to predict the next word. So we talked about filling in the blank, but that's not actually that's part of the process of how it's trained, but that's not actually what Chat GPT does when it's being used in practice. So it's always trying to just predict the next word. So the cat sat on the, and then fill in the next word. Matt. Oh, and actually I should delete that period because the period doesn't belong there. It would come, that would be the next thing to predict, right? Okay, so there are different kinds of large language models, and ChatGPT is something called a decoding only model. And if we have encoding, it means we try to map the input into a mathematical representation through those layers and layers of mathematical transformations. And then we have a parallel process that tries to work out that based on that output vector, what is the output we should produce from that. So this is often used in the context of machine translation. So we take a whole input sequence, a whole sentence, say, and then try to figure out what the whole sentence should be that corresponds. And again, it's done using these neural network models. And what transformers really does is basically try to say, all right, we have words, but they're not really isolated. These words live in the context of a whole sentence. And so rather than just thinking about this exclusively as a word comes in, a word comes out, we want to try to capture the fact that these words are connected to each other. And so that means that in the actual training of the model, and then in the encoding and decoding process, in each of these steps, we try to make sure that there's influence of words in the context on others. And the really important thing about this transformer algorithm is that it allowed us to move away from where we started at the beginning, where I said there's one vector for one word. So we had cat and we had a vector, right? What it allows us to do is acknowledge that words can actually have different meanings depending on what context they're used in. So cat's pretty easy, but a word like apple can mean different things, right? You have apple. I actually have one on my desk. So you have apple, the fruit. That's my snack for later. But you also have Apple, the computer company. And in fact, I'm talking to you on my Mac. So that's, the Apple Mac. And what if we have a one-to-one relationship between a word and a mathematical representation of that word, then those two senses of the word get mixed up in that representation. And it means that we have a difficult time kind of really understanding the context in which that word should be used because they're mixed together. So with the transformer model, what it allows us to do is build a representation of a word in the context of the whole sentence or paragraph, which is different if that word is being used in one way than another. So if we have a sentence that says, the apple was fresh, then that would kind of push us towards one representation. But if we have a sentence like the apple was brand new, I don't know, that might push us more to the technology interpretation. And definitely if we have words like healthy, that would probably be push us towards one representation of apple, and computer would push us towards a different representation. And the apple's expensive, yes. So really all of this combines so that, the deep learning, all of these layers combined with the transformer method, which allows us to incorporate information from other words in the context. So when we look at that fill in the blank, the cat sat on the mat, we're not just looking at only the word that comes before or the word that comes after. We're looking at all of the words in the context simultaneously. Means that we have a very powerful representation of the text. Can the computer understand periods and capitalization? It depends. And by the way, people don't consistently use capitalization anyway. So if you're, sending messages to somebody about your new Apple MacBook, you probably won't bother to capitalize Apple. So it's not a reliable signal, although of course it can be information that's used by the model to distinguish between the two. But remember that apple, the fruit, can also appear at the beginning of a sentence or in other contexts where it might be capitalized. So again, information not completely consistent. Okay, so in Chat GPT, all of this combines, and what it's trying to do is build a representation of each word in the sentence, and the job of the model is just to predict the next word. So it literally is that job of fill in the next word in the sequence. It's just doing one word at a time, and when it produces a word, then that word becomes the next word in the sequence, which then drives the prediction of the following word in the sequence. Okay, so in a nutshell, what do we have here? We have a very highly representative, competent generative language model, very large, sophisticated mathematical representation of patterns and word sequences derived from a massive data set, which comes from the internet, improved by large amounts of human feedback. And basically what it's doing is it's copying, manipulating, and pasting back together in the generation the words from text that humans have already written. So my friend, Emily Bender, who is a computational linguist at the University of Washington, she and colleagues have referred to this as a stochastic parrot. It's basically parroting back to us. There's that word stochastic again. It's parroting back to us the words that it has already seen. And it might be combining them in slightly different ways than it's ever seen before, but that's only because it's following the kind of statistical probabilities of the model. Okay, So when we have these kinds of models, we need to think about what can go wrong. And at the moment, we've only actually been given fairly limited details about what's been used to train Chat GPT. And so there's a couple of things that I just like to point out. If there is bias in that input, and there almost certainly is, then these models will learn the bias of that data, and that means that it will produce bias, right? So if what is in the training data is biased in any way, then it will produce things that are biased. And we've been hearing a lot about this lately, particularly in relation to the image generation systems that are, for instance, only producing images of men in response to an input like CEO, right? So this, of course, there's biases in the data itself, but they only get entrenched in these models. The other thing to note is that there are lots of languages. I don't know how many of you speak a language other than English, but it turns out that actually these large language models are not so good at less represented languages. Now, languages like English and Spanish and German and French are probably okay. Chinese is less okay because a lot of Chinese data is behind a firewall that the American tech companies can't get access to. Of course, they're building their own large language models for Chinese, so that's going. But languages like the Indian languages or Vietnamese, even though Vietnamese is spoken by millions and millions of people on the planet and plenty of internet sites, it's not captured as effectively in the model. Also, because the pre-trained models are pre-trained, they end up being out of date pretty quickly. So you're not going to be able to use these systems to find out the latest news, right? Because they don't have access to it. It's not being updated on a day-to-day basis. It's too expensive to update these things all the time. Now, of course, the tech companies are trying to keep them refreshed, and the 2021 date that we have for Chat GPT was when it was first released, and I think it's been updated since. We also need to be thinking about the fact that it confabulate. So a lot of people use the term hallucination, so that these models are basically making things up. I prefer confabulation, mainly because humans hallucinate, machines don't. That's a very kind of human trait to have an experience where your mind tricks you, right? These machines don't have minds, but we can say that they're confabulating. They're making things up. And they can be harmful. So they can produce outputs that are biased, but also actually incorrect, flat out incorrect, which may result in harm. So we just need to be aware that these things, that these issues can occur. And I think we also need to emphasize that we think of back to the question about how we learn language and how we use language. We do a lot of things that these machines don't. So we don't just think about the way words and concepts connect words and terms connect in terms of the co-occurrence patterns. We think about them in terms of how they relate to each other, and we're constantly abstracting at a conceptual level, right? We don't just think of dogs and cats and pets as independent words that are in this space. We think of dogs and cats as a type of pet, and that the fact that we have a hierarchical relationship there is actually important for how we try to organize and put structure on the world. We as humans are really good at reasoning over abstract, complex information. And Chat GPT is not. It's really working down at that word probability sequence level. As I said earlier, it's not grounded in the real world, right? So Chat GPT has a representation of the words in the text, but doesn't understand, what that word actually corresponds to in the real world. By the way, I didn't intentionally bring the apple to use it as a prop, but it's working for me, so I'm going to keep doing it.
Good job. Don't eat it.
Okay. And of course, it's not really interpretable or explainable. I tried to explain to you in a hand wavy way what the maths all represents, but it's actually not possible to look under the hood, look inside and go, right, that's where the representation for Apple lives in the model. And that's because we've moved so far away from that one-to-one correspondence between a word and the representation. The representation is actually all of those layers of multiplication, which we just cannot wrap our heads around. I'd also like to reinforce that Chat GPT is definitely not sentient or conscious. You hear a lot of people getting kind of scared about AIs taking over the world, and I just like to remind you that it is a statistical model. So don't be scared that it's going to take over the world, because it really isn't intelligent, okay? It's a machine simulating very well the linguistic capabilities of humans. And as we already talked about, it's not acquiring language the way we do.
Yeah, and that links to Maya was pointing at something that came up in the news, is in the chat. What we consider proper or improper behavior depends on the culture.
Yes.
So how you, for example, in Spain, when you introduce yourself to a new person, you might kiss them on the cheek, right? That would be unheard of in other countries, right? So cultural correctness is something that is a human and a knowledge kind of thing, right? So a robot wouldn't know unless it's trained otherwise. And Sonia was asking, in what situations would you not use the Chat GPT?
Okay, so let's keep going, because I think I'll answer that.
Okay.
So I'm going to move, and I have way too many slides, and you guys are asking a lot of questions, which is fantastic, but it means I won't get through all the slides, but that's okay. We'll just focus on the things you're interested in. But I think we're gonna answer some of that along the way. Okay, so we talked about how ChatGPT is based on a ton of data, right? And what is that data? It's what you can think about. We have a bunch of web pages that it's ingesting. There's something called the Common Crawl, which has basically collected as many of the web pages as are accessible. And it was developed for research purposes, but now it's the foundation of these models. Of course, there's a lot of social media in there. So it's ingesting Reddit and Twitter or X or whatever it's called these days, and Facebook, and anything that it can get its hands on, it's ingesting. And then there's also books that are being ingested. So anything that's in Wikipedia, anything that's public information. There's a thing called Project Gutenberg, which is basically books that are out of copyright. And there's another corpus called the Books Corpus. And if you listen to modern authors, they'll tell you that their works have been ingested, probably illegally. But anyway, that we don't really know, because ChatGPT, OpenAI doesn't tell us, but that's where this is all coming from. So it's coming from the internet. Okay, so should you use ChatGPT as a search engine? This is the first thing that people started trying to do with ChatGPT, right? To use it to answer questions that they had, or to learn something new. And certainly from a scientific perspective, we want to be careful with using these systems in that way, because they don't reference the sources. That means that we don't know where the information that's being provided to us in response to a question, where it comes from. And the text where the answer came from may have been very unreliable, right? Imagine, trying to make medical decisions based on stuff that's ingested from Reddit. Never mind the fact that there's plenty of intentional misinformation on the internet as well, right? So there's lots and lots of people trying to put information out there to influence people without it actually being grounded in truth. And also one thing, and this came out of one of the questions that you all sent in advance, and it relates to the personalization question we had earlier. There isn't actually personalization, and it's not remembering things at like the specific level of detail. So I can give you an example of that. I once gave a talk just like this one, all about ChatGPT, and the organizers thought it would be fun to ask ChatGPT to write my bio. So instead of asking me, they asked ChatGPT, what has Professor Karin Verspoor done in her career, or something like this. I don't know what the prompt was, but anyway, it put me in the right space. So it understood that I was an academic in Australia, and that means that I might have funding from the Australian Research Council and various other things. But none of it was actually correct at the detailed level, right? So yes, it understood that I'm an Australian computer scientist, and then it made a whole bunch of assumptions about things that would be true because of me being a professor in computer science in Australia. And for example, there's a very competitive fellowship called the Australian Research Council Future Fellowship, which I've never been eligible for because I came here to Australia way too late in my career and I timed out basically. But because I have the right profile, it attributed this fellowship to me. It said I won this prestigious fellowship, and it wasn't true at all. So that's an example of where I'm in the right space, right? It's kind of put me in the right semantic space with my peers, but the details are all wrong because it doesn't keep the details. It gets hidden away. Okay, so I thought it'd be fun to go to Google and ask Google what people are trying to use Chat GPT for. And so I just typed into Google, should I use Chat GPT for, or should I use Chat GPT to? And this is what came up. So this reflects the queries that people are asking Google, right? Because Google also tracks, oh, what are the most frequent queries? So should I use Chat GPT for my cover letter, for my resume, for school, for coding, for college essays, for work? Okay, to write a book, to make money. Well, I don't know how you're going to make money off of Chat GPT, but anyway, OpenAI certainly is making hands over fist. But these are the kinds of things. And I guess if we're trying to answer the question of like, what should we use Chat GPT for, then these are some examples of how people are trying to use it. What do you all think? Should we use Chat GPT for coding? Anyone? What about your schoolwork? Might help with debugging. No, not for schoolwork. Okay, why not? Do your own work. Right. Okay, here's the thing. I think it's actually okay to use Chat GPT for probably most of these things. However, you already have to know what you're trying to say, and you have to have the ultimate accountability and responsibility for what you're producing. And so some of you said it was okay to use it for coding, maybe even for debugging. And that is one of the key applications that Microsoft is selling, right? They're saying you can use GitHub Copilot to help you write your codes. And yeah, so Soumya has written, I'm sorry if I'm pronouncing that incorrectly, but maybe for suggestions. That's the point here, right? You can use these systems to kind of, I don't know, help break writer's block or help get you going. And that's a reasonable thing to do. But ultimately, you need to know what it is that you're trying to achieve. And you have to be able to look at it with a critical lens. And I would suggest that even for coding, which seems relatively straightforward, if you don't actually know how to code, then you have no critical framework for deciding whether or not it's right or wrong. And then remembering that it's going to make things up and it's going to be sort of statistically valid combinations of things, but not necessarily actually solving the problem that we want to solve. So Microsoft is now selling, Copilot, making Copilot available as your everyday AI companion. And back to the cultural point, they're already starting to incorporate some variations into it so that you can have a more creative style or a more balanced or a more precise style. And that controls kind of the stochasticity and the dynamics that are in the use, but it also controls exactly what language is used. And I have a nice example later, which hopefully I'll have time to get to, but I also want to point out that the landscape is changing and very, very rapidly. So, a year ago, we only had Chat GPT in the mix. Now we have Perplexity, for example, which if you look here, starts to incorporate sources. So it's combining the question answering capabilities of something like Chat GPT with search. It starts to pull in sources. So it gives you the answer, generates the answer, but it also provides you with some sources. There's one that's specifically targeting scientists, this one called Cite. And so here's an example. How does the structure, and by the way, these are just examples that are from their front page, so I didn't make anything up. How does the structure of a protein affect its function? It's generating this output, but then it's providing actual pointers into the scientific literature to support the statements that are in that generated answer. So that means that we're starting to put in some controls, some guardrails, if you will, for trying to have more reliable information coming out of these models. But you can do all sorts of things. So Microsoft Bing now, you can ask it to create a table that compares top selling women's running shoes. It will literally create a table. You can see it writing out the columns and putting the information into the table. But then of course they show you some ads alongside of it. And what I found interesting about this particular example, which again was just one of their standard default examples, is that the things in the table here don't match completely to the things they're trying to sell you. So there's still a little bit of a disconnect between, kind of what's under the hood in terms of the shopping algorithms for the search engine and the information that's being generated. Not quite lined up.
Isn't Amazon, I think the reviews now have a summary, and it, like before you had to read every review, and now it gives you a summary. That's probably AI generated, right? Like say,
I'm sure it is. And summaries are one of the areas where I think it's probably okay, although there's tricky things around how you actually deal with differences of opinion. So if you have, like 2/3 of the people say one thing and then 1/3 says the opposite, how do you deal with that? It's quite it's still work in progress, put it that way. But yes, they're definitely trying to leverage. I like this cartoon, because I think it kind of highlights some of the craziness of the world that we're living in today. So, we can use this Copilot thing to turn a single bullet point into a big long email that you can pretend you wrote, and then the person who receives it can use AI to turn that single bullet point into a long email I can pretend I read. I mean, what kind of world is it that we're moving towards? And again, the reminder from Copilot that you need to check for mistakes. And so I think the basic question, and we've alluded to it in your responses in the chat, is that you cannot check for mistakes if you don't have some sense of what is correct. So if you see see this as a suggestion, as a rough draft, as a starting point, that is okay. But again, you have to know enough in order to have that critical lens on what it's producing, and make sure that your that the information that it's giving to you makes sense to you. So I think we need to be just a little bit careful. And I'll skip this because I'm just running out of time. But I can send through the slides, and then you guys can read those examples if you want. Yep. Okay. And I just wanted to point out that if you use Chat GPT for creative works, like the one I asked it to do just then, it produces extremely boring stories, really boring. So, and here's a nice example. You all know I work in the biomedical context. So I asked Chat GPT to create a treatment plan for a patient in acute pulmonary edema, which is a particular medical condition. And it tells me appropriately that it is a serious condition that requires prompt medical attention. But the treatment plan basically says, go to the emergency, run some tests, and prescribe some drugs. And it's really not much more specific than that. And the funny thing about it is that, if I ask it to create a treatment plan for a patient in acute pulmonary edema, well, the patient's already there and I already know what's going on. So really it's only the medications, and this is completely useless. may include this, may include that. Anyway. Okay. The other questions that came up that you all sent through, a number of them had to do with ethics. And so I just wanted to sort of touch on that briefly as well. And one particular thing that applies in the context that I work in is that, you know, these models are controlled by American corporations that have that we don't know what they do with what you upload into these things. So be very careful about what you put into the prompt box in Chat GPT, because if you put in some very sensitive information about yourself, or worse, if your doctor puts some very sensitive information about you up into one of these systems, we don't know what's going to happen to it. And there have been examples that have been come out in the media where very sensitive information has been leaked because it was absorbed into this system, and then it just came out in a generated text at the other end. And you know, we really have to be thinking about who has accountability for the outputs, for the decisions, for you know, the information that's provided by these systems. And I think everybody who uses these systems is accountable for how they use it and the outputs that they take for their own purposes. Okay, lots more. I will, oh, this is a funny one. I'll tell this one and then I'll probably stop because you all have better things to do than listen to me on a Saturday afternoon. But one of the things, again, related to this question of culture and, you know, human-like, there was a funny study that was done actually quite early last year, so not long after Chat GPT had been released, and they had US-based physicians, clinicians, doctors respond to various people on Reddit, and they had Chat GPT also respond related to various health conditions. And the people judged Chat GPT as more empathetic. Okay, so over here, more empathetic than the clinicians. And in general, they preferred the responses from Chat GPT to the responses from the doctors. So, you know, now this isn't correctness. Okay, so the doctor, we do know that the doctor's responses were more correct than Chat GPT's responses, but, you know, Chat GPT can be very convincing. Right. And oh, yes, let me tell you. And one thing, you know, doctors are not necessarily known for their patient bedside manner. And so, you know, maybe this is a way we can get AI to help them is, you know, to remind them to use their please and thank yous and, you know, these sorts of words in their responses. So I'll just say, this is my friend Emily, and this is, you know, not a real parrot, but she says, you know, you are not a parrot and a chatbot is not a human. And I think it's really important that we remember that. And I love that Emily is out there telling the world this. So in short, do you need to know anything? Yes. Always approach information with a critical lens. Think about the utility of this technology before committing to using it, right? Or committing to using its outputs. And of course, what can go wrong? And remember that this machine does not understand things like we do. And so we really need that human brain to make sure we do that. Yes, of course. And so I'll just say you are not a parrot. Thanks.
Thank you so much, Karin. I think that's the Sage Live event when I've seen most activity and questions and so on. So that's fantastic. I think our students are very interested in understanding, again, from the ethical boundaries to the understanding who controls those answers and things like that. So someone was asking, I think we tackled already the ethical and unethical use, but you know, like, for example, the summaries on Amazon's choice products, could they be biased?
Of course. Yeah. I mean, look, anything can be biased. All the algorithms that we use can be biased. I mean, the same is true in Google search, right? You go to Google search and they have sponsored ads, and so, you know, of course there's been pressure on them to make it clear when you have a sponsored link as opposed to just one that comes out naturally from the algorithm. And so, you know, these kind of reminders in the visual design of the system that this is maybe influenced. But the problem is we don't always know when something is biased, right? So because of the fact that it's just parroting back stuff it's seen, it's very unclear when the stuff it's seen was biased in the first place. And so it's not easy to kind of tell. And there's been, you know, the controversy recently around the systems now being biased in the wrong direction, right? So producing nothing but African faces in response to particular prompts. And, you know, then things become, you know, we're trying to overcompensate essentially for the bias in the system. And so we need to find some balance.
So I think in terms of bias, we are biased, right?
Yeah.
As well, we humans are biased. So how can we humans can deal with it is that by acknowledging it and balancing. So
That's right.
knowledge, what you guys do about having a critical thinking, you know, question yourself, right? Am I doing this for the right reason, for the wrong reason, and so on? That's
Exactly.
the key. That's the
And
key. And a computer won't.
Yeah, I mean, look, there are some really nice examples of where AI is being used, for instance, to screen resumes. And they have found that AI assisted resume screening is less biased than human resume screening. There was a really famous study that was done a number of years ago, which was about humans. Okay, so they gave people who were trying to recruit for a job the same resume, and on one resume the name was Jane, and on the other resume the name was John, right? And the outcomes for Jane and John were very different. So basically John got the job and Jane didn't, right? So I mean, you know, AI systems can be set up to control for those kinds of things, right? So you can mask the name and make sure it's not part of the evaluation. It's tricky though, because like you and I, Anna, but on our CV, on our resume, we have something like, you know, Women's Diversity and Inclusion Group. Well, as soon as you have that somewhere listed on your resume as an activity, or a girls' science program, right? All of a sudden it identifies you as being in a particular group. And so, you know, we have the data is always going to be biased. Whether the algorithms make use of that in their decision making or not is up to the people who design the decisions, these systems. And yeah, I think we just need to be really open-minded, and again have that critical thinking on how these systems are built, how we're using them, and watch for those kinds of problems, and then hopefully try to mitigate for them. I give another whole talk, which also you can find on YouTube, about diversity and inclusion in AI. And one of the examples I give in that talk is a self-driving car. So it's nothing to do with large language models, but I always ask people, would you drive in a self-driving car that was designed and developed exclusively in the United States if you were planning to drive it in India? Yeah, and Anna's face is like, no, right? I see lots of heads going, no way. Why? Because the assumptions that are baked in, you know, into a car that's been designed and tested in the United States, it means that you're assuming a certain kind of road, you're assuming certain lighting, you're assuming, you know, lights, you're assuming lane markings, and you're assuming, you know, the models incorporate information about other cars on the road, and all of those factors are different in a place like India or Thailand, right? The roads are just completely different. The layout, what's on the road is completely different. it's, yeah. And so this has nothing to do with like, gender bias or anything. It's just about experience, and you need different perspectives always to kind of ask the questions of like, okay, what assumptions am I inadvertently baking into these models?
And always remember, Tim, that the human brain is an amazing tool. We are able to choose the words we use with John, Peter, Mary, or Jane, because we know that if we tell John you gain weight, he's going to say, fine. If we tell Peter you gain weight, he's going to be depressed for a month, right? So we have that level of knowledge and critical thinking that make us choose the words. And that's something that it's going to be very tough for a computer. So when we hear about this threat, I remind people, go back to the steam engine revolution. People were scared about the steam engine. It just allowed us to create the right thing with the right regulations so we can spend time doing other things. We humans are capable of doing other things, right? So we can spend time doing other things. And the steam engine can do their thing inside their box, right?
Yeah, this AI assistant model is quite a good one, and there's lots of evidence that it can save time. For instance, another thing that Microsoft is trying to sell right now is a system that listens to a meeting like this, takes notes and then summarizes it, and maybe if it's a proper committee, then you have action items and things like this. We wouldn't have that, but oh, well, actually, you gave some action item. Go look up the word stochastic, right? So, that could be an action item. So like that kind of tool could be really helpful. Now, would you want to just have it generate it and send it out? No, you want to review it, make sure that it didn't capture anything inappropriate, and didn't, disclose people's identity unnecessarily, et cetera, et cetera. So yeah, always there's absolutely, these tools are here to help us, right? And I've been working in this area for decades, not because, well, for two reasons. One, I think it's very cool, but two, actually these machines are very powerful, and they can find patterns in data that we can't find on our own. And the kinds of models that we can build using machine learning really are very important tools that can be used to help us do all sorts of things better. One of my areas is to try to help scientists by essentially machine reading papers and synthesizing the information in those papers. And I always start by asking people, how many papers can you read, right? And most people, they think about it maybe in terms of how many books you can read every year. You're reading what, like, maybe 5, 6 books a year. I don't know. Scientific papers, if you're a scientist, you might be reading 2 a week if you're lucky. But there are millions, literally millions of papers, and I don't know how many books being published all the time. And so you can use a machine to help you kind of sift through and navigate and help you do that.
So Delia was asking, can these models only do language, or do they understand mathematical concepts like calculus or physics?
Yeah, so again, this is an evolving landscape, but certainly the early Chat GPT was completely terrible at doing anything that required actual calculation, because it was just treating numbers as strings, right? And it didn't really understand the relationships. Now it is progressing, because somewhere along the line, somebody figured out that if you have a string that looks like 12 plus 5, that they can just turn that into a calculator calculation, which calculators are pretty good at solving. We don't need a large language model to solve that. And so they're kind of adding, like, there's a little calculator on the back end now that's going to be doing that. But it turns out that numerical reasoning is still a very, very big problem for these models. In fact, it's the topic of one of my PhD students' thesis, is really exploring how numerical reasoning works. And bottom line is, these models are really, really terrible at numerical reasoning. So, if you say something like, like the word problems you did in elementary school, right? 5 children have red pens and 3 children have blue pens. How many pens are there altogether? And Chat GPT will go 5. Or something, right? So yeah, no, the answer is it's still not quite a solved problem. Another one that's really funny is another topic for another one of my students, looking at negation. So if you have a question and you're asking for the answer, and you ask the same question but negated, so like, I don't know, I can never come up with examples off the top of my head, but like, what is not the capital of the United States or something like this, it'll just tell you happily Washington, D.C. Because it literally doesn't even see the word not in there.
Hey, Karin, since you mentioned your students, what's the background of the students that you that you direct?
Well, most of my students are still computer science students, but I have a mix. I actually have a student who is a musculoskeletal therapist. So she physiotherapist. And she got really interested in how we could use data in the electronic health record to try to understand outcomes. And so she's training herself on a bit of mathematical modeling and trying to learn how to build AI systems. So I think the landscape is changing. Maybe even with the help of some of these tools, we're going to be in a place where it's going to be much easier for people to build their own machine learning models and think of different ways we can use these systems to solve problems, so more in the application space. Whereas, the computer scientists are the ones worrying about exactly what this deep learning architecture looks like and what algorithms we use to infer the models and train the models. But now we can think a lot more about how to use the models, and people from all kinds of backgrounds can contribute to that.
And Sandy was asked, or someone else, Holden. Oh no, sorry. Someone was asking, what's the difference between Siri and Chat GPT?
Right. So Siri is voice, right? It's using speech recognition. And it's still, well, so Siri, Alexa, Cortana, they're all a bit older than this technology, because they're focused essentially on trying to take the spoken voice and then transforming it into something that they can act upon in the technical environment. We're going to obviously, so like you can say, Alexa, turn on the lights or whatever, right? And so you can use your voice to initiate an action. But the connection between the voice and the sophistication of what we're asking it to do is still not quite there. So that's something that will, I'm sure, be accelerating a lot now. We're going to see a lot more useful tools. I find, like, I have an iPhone. I find Siri quite useless for me. Like, the only time I use Siri is if I'm wet coming out of the shower and I want to know what the weather's going to be today. That's pretty much the only time. Yeah, because then I can't use my hands because I'm sopping wet, but pretty much everything else, I get frustrated because I ask it an actual question and it just tries to read links on the internet, and just, no, that's not helpful to me.
Siri doesn't understand my accent.
Yeah,
that's another thing. Someone asked, how will AI alter the landscape of healthcare? And what are some of the cons and the pros? And you give an example about, bedside manners and so on, but.
Yeah, no, so look, I it's funny because I've been going around for about 10 years trying to convince clinicians and doctors that they should talk to me, because there's so much potential to use AI in the context of health data. And actually, if I go back to my slides for just a second, I had a few slides on that. Let's see. I'll just talk to them quickly while I'm answering. So there's some places where in the delivery of healthcare, we can see AI already playing a part. So here's a picture of, you know, patient with a doctor, and using things like the voice recognition and mapping into text. We can imagine a doctor actually looking at the patient and having a conversation rather than looking at the screen, which is what happened. I don't know, when I go to see my doctor, you know, inevitably they're looking at the computer, typing stuff in. It'd be very nice to actually have a conversation with them. And I think for both of us, right? And so AI, this is already happening. So we're seeing AI being used. It's we call it kind of an ambient listening kind of scenario, where the AI is just kind of capturing the recording and then taking notes for the doctor. That's one obvious thing. Helping documentation, clinical documentation, particularly in the US, by the way, is a huge burden for clinicians. And so using AI to kind of help summarize, you know, a 15-minute consult or whatever will help a lot. We're already seeing robots in use in surgery. They can be extremely precise, right? Their hands don't shake, they don't get tired. You know, they have perfect vision. And so there's really good opportunities for use of robots there. And you could imagine a kind of, you know, a robot assisted surgeon, where the surgeon is actually sort of talking the robot through what it's doing, but the robot might actually be doing the incisions or what have you. We even see social robots. So in places like aged care facilities or retirement homes, the robots that go around and actually engaging with residents is being shown to be really valuable to people. You know, as much as robots aren't people, it can still play a kind of social role to help people kind of keep talking and be engaged in the world around them. I know, Anna, you and I both have robot vacuum cleaners, and I have you know, we call our robot vacuum cleaner Dustin Cleaner. Rhymes with
ours is Sebastian.
Okay, well, he's Dustin Cleaner. Rhymes with Justin Bieber, sort of. And you know, I joke with it's a he, it's not a, you know, it's not a it. And I kind of joke with my family. Yeah, Sebastian's a he, right? I mean, obviously we know it's an it, it's not a he, but on the other hand, there's something about these things that move around and talk to us that I mean, that those don't even talk to us, like we still anthropomorphize them, right? Yeah, there's something about them. Anyway, and then there's lots of you know, sort of operational things in hospitals that can be helped with automation and AI, trying to predict things like how many hospital beds are we going to need in the next few days, how many surgeons might we need to have on call, that sort of thing. One of my PhD students has been working on using the notes and the progress notes in the hospital to help try to predict the demand for services in the coming days. Then there's the more data-oriented view. So this is where we see a lot of opportunities for using AI. So computer vision at the moment, image processing is the most mature. So we have lots of examples of AI systems that can essentially look at an image or a sequence of images and find patterns in that image that are indicative of various diseases. So we see it in the skin cancer space. You can use an AI tool. It's actually more reliable now, they say, than the human, to try to detect suspicious lesions on the skin. And same for like measuring the size of a tumor or detecting a tumor in a chest scan, perhaps, or a brain scan. That's already working very, very effectively. And there's companies that are, really focused on building systems that support clinicians or support radiologists to be able to make use of these tools in a safe way. And then there's a lot of the work that I do is around what we call real world evidence. So basically the idea behind this is, we have all of this clinical data that we're capturing in digital systems, in electronic health records, in primary care, practice management systems, basically the doctor's typing into a system, right? So that means we're capturing information digitally. And we're not using it really. We're using it for documentation. We're using it for, insurance and billing purposes, but we're not using it for actually modeling health. And I give another whole talk where I talk about exactly how we can do that and use the data. But to me, that's a really, really valuable thing. And in the personalized medicine space, we talk about kind of looking at your individual genomics to help guide things like treatment selection. And these two things can combine because, for instance, there are people out there with very rare diseases, rare meaning, one or two might be seen every year in a particular hospital. But if you combine the data from the whole world, you suddenly have, 100 people. And then you can start to compare and contrast and make some decisions around that. And so if we can kind of gather the data, compile it in a safe way again, and then we can start to model the data, and it can be really useful for guiding things like, well, I have a patient with this particular set of characteristics. Should I choose this drug or that drug, right? And the way we do that now is by doing clinical trials and having scientific evidence that says, well, patients that meet these criteria, this is the better choice, and patients that meet these criteria, this is the better choice. The problem with that is those are always limited samples. You can only run a clinical trial with whatever, 500 people maybe, max. Some of them are done on 50 people. So, that's not really representative of the whole population. We can get evidence and data from the whole population if we look into the machines, but there's no way that we can do that manually. Right. We need a machine to dig through all of that information.
So yesterday was International Women's Day. So and I'm saying that to, say happy International Women's Day to you all, and remind you that many of the things that we hear now that AI is doing is what women were doing at the time when we were not allowed to go to college. Women were the computers in the astronomical observations, right? We would take pictures of the sky, and these ladies that were not allowed to be professors like Karin, right, were spending their days looking at slides, pictures, and seeing if the light changed in a particular place. And that's how we identified and explore space, right? If AI can do that now, that doesn't mean that we are out of our job. That means that we can, thanks that the fact that we can go to college and be allowed, we can kind of push further the boundary of knowledge. So when new technologies come, we are always scared. I mentioned the steam engine. Here, when computers came, we were scared, and there's always people thinking, oh, all the jobs are going to be lost. No, human brains are amazing. We have things that computers don't have, neuroplasticity. We can develop, continue to develop things. So always use your critical thinking. That's something that we have that artificial intelligence doesn't have until someone like us puts it in. And yet it's going to be hard for it to evolve. And it's 4 p.m. I know we are out of time. Thank you all for sending all those questions. And I think I want to ask Karin the last question that relates to the student's life, right? So one question was, how do English educators or an educator navigate essay writing or grading when cheating is easier now than ever, especially in high school and AP level? I'm sure in your college, I know in American colleges, professors are given tools to ensure that the students are not using AI for the wrong purposes. But remember, you all students, cheating is is against you, because the whole purpose of going to school is to learn. To cheat to get a good grade, you don't learn. It's going to catch up with you sooner or later. So Karin.
Yeah, it's a complex space, and we're all kind of grappling with the best way to navigate this. And I come back to, there's some things you just have to know. Because if you don't know what the right answer is, or you don't know what the correct information is, or you don't know the correct way to solve a problem, or the pros and cons to different solutions to solving that problem, then you won't be able to look at the outputs of a system like this and really judge whether you can use that or not, right? And so in order to have a critical lens on anything, you need to have the foundations in place. On the other hand, we recognize that these tools exist. Nobody's going to bury their head in the sand and pretend they don't exist. And so we're also kind of trying to incorporate Chat GPT and other systems like it into the education process, so that people can understand in a very real way what the limitations and opportunities of the tools are. And so they're increasingly, people are trying to use Gen AI to actually as the basis of an assessment in their courses. So for instance, you can ask students to, in fact, my daughter, who Anna knows, Catalina, she was just telling me that one of her assignments in one of her classes this semester is to use ChatGPT to write a short essay, and then she has to critically analyze it to kind of poke the holes in it and what it got wrong, right? And these kinds of assessments serve two purposes. One, to test whether you actually have the knowledge to do that critical judgment, and two, to understand that these tools are not perfect and you shouldn't rely on them all the time. So I think we're going to see, kind of integration of these tools into the learning process, rather than seeing them as like, just bad and try to ban them. But there are limitations. So, we're struggling with this in our first year coding classes, because you need to get those basics down. And funnily enough, all the students get it, right? We ask them, like, who in this room thinks that we don't have to teach coding anymore because ChatGPT is just going to write the code, or GitHub Copilot's just going to write all of our code for us? Nobody put up their hand, right? So all of the students, I think all of you understand that there's just some things you need to know. That's it. You just need to know some stuff. That's part of the learning process.
How do you grapple as a professor, grading your students' essays, theses, and stuff like that? I mean, what guardrails can you put in place?
I mean, obviously, until we had these very openly available large language model based machines, we could use simple plagiarism detection. So most of the plagiarism that was being done was pretty much copying and pasting, right? So that's pretty easy to detect. We're in a brave new world where, how do you detect these? The outputs of these systems are very good. On the other hand, as I said earlier, they're fairly formulaic. They're kind of the average of everything, right? If you think about it from that statistical sense, it's literally just the average of everything. So they are kind of boring. And so there are hallmarks. But this is an ongoing research question. I'm involved with the natural language processing community. I was just reviewing a bunch of papers that talk about essentially strategies for using large language model based systems to kind of police other large language model based systems. And so, you know, basically, how can you use these tools together to detect the bad behavior of the other of the, or the, not the bad behavior, but the existence of these tools. And so I think we're going to be seeing kind of, you know, plagiarism detection tools evolve and get better and better. And it will be because essentially of the limitations that we know exist in the current pre-trained models.
Super. We want to be respectful with your time, Karin. It's 4:09 New Mexico time. We want to thank you all, students who joined us today. It was an extremely successful day. We might need to bring you back, Karin.
There's always more to talk about, as you can tell.
There were lots of questions when you guys joined the session. When you registered, you asked a lot of questions. I believe I heard Professor Verspoor saying you're going to share your slides, and
Yep, happy to. Yeah.
so if you would like to get her a copy of her slides, send an email to info@mysagejourney.org, and we will share those with you. And we will also put the YouTube video online as soon as we are done. We ask that you all follow us on social media at Sage Camp. We will have another session in April. And I think Daniela is going to put that there. Fantastic. The next session is going to be in April 27th. And it's about what I wish I knew when I was in high school. So again, remember, all of us are here to help you. Ask for help. Asking for help doesn't mean that you're a loser. It means that you want to grow, and we all ask for help. Karin asks, Professor Verspoor asks for help, and we all ask for help, and it's okay. So with that said, I think we're going to stop the recording and check with Professor Verspoor if she needs to go back to her family.